All right, we're going to talk about imaginary and complex numbers and exactly what they are, where they come from, how you write them, how you operate with them, so add, subtract, multiply, divide. So first, in your notes, you can see that the definition of an imaginary number is it's the square root of -1. You can't take square roots of negatives, they're imaginary. So when you do it, you can work with them mathematically, but they're not real numbers. So if you have this type of solution, it's not going to show up on your calculator. So for example, if we see a problem like the square root of -81, the first thing I do is I'm going to make this a positive and just put an I in the front. And then I can go ahead and say, all right, I know what the square root of 81 is, it's 9, and so my answer would be 9i. For a second example, let's say we have the square root of -108. All I have to do is make that negative a positive, put an I in the front, and I'm done. That's my final answer, is I square root 108. Now, it gets a little bit trickier when we start talking about powers of I. So if you look on your notes, we know that I equals the square root of -1. And so I squared is the square root of -1 times the square root of -1. Well, anytime you multiply a square root times itself, what ends up actually happening is the square roots kind of like cancel each other out, and then the number that you had underneath is just kind of your answer. It's just -1. And we can't type in square root -1 times square root -1 into our calculator because our calculator can't do that. But if you try multiplying like the square root of 5 times the square root of 5, you'll see what I mean. So there you can see it. When you multiply a number underneath the square root by the same number in the square roots cancel out, you just get the number you had underneath. So two important things to remember. First is that I equals the square root of -1, and almost more importantly is that I squared equals -1. So when we start talking about powers of I, let's say we have like I to the third, you can think of this as I squared times I, and we know that I squared is -1, so it's kind of like having -1 times I, which is -1I. If we have I to the fourth power, I could think of this as I squared multiplied by I squared. Well, each of those I squareds are -1, so that's like -1 to the second power. It's -1 times -1. And that just equals +1. I to the fifth is the same as I squared multiplied by I squared multiplied by I. So here, if we look at this, it's like we have a -1 to the second power because we have two sets of we have two I squareds. And then we have an I on the end. And so -1 squared is just +1 with the I on the end, so +1I. If we look at I to the sixth, this is like I squared times I squared, which is like -1 times -1 times -1. So I'm going to say this is -1 to the third power. -1 to the third power is just -1. I to the seventh equals I squared times I squared times I squared times I. So if you look at this, we have three sets of -1, so three -1s and an I on the end, so that's -1I. So when we're looking at exponents of I, we just have to think how many sets of 2 are in there, because the number of sets of 2 that we have is the number of -1s that we have. So if you look at I to the eighth, I take 8 and divide it by 2. That would be I squared, I squared, I squared, I squared, right? So that means that there are 4 sets of I squared. So this is -1 to the fourth power because there are 4 I squareds. Since 8 divides by 2 evenly, it means we don't have any leftover I's. And so -1 to the fourth power is +1. So now we're going to have some exponents that we probably don't want to draw out. For example, they ask you to simplify I to the 19th. So first we just want to see how many I squareds we have. So I'm going to do 19 divided by 2. And 19 divided by 2 is 9.5. So the way you can think of it is the whole number there, that 9, that's how many -1s you have. So that's how many sets of I squared. If I do I squared 9 times, that would be 18 i's altogether. So I'm going to say this is negative 1 to the 9th power. That's how many sets of negative 1 we have. And then the 0.5 means that 9 does not divide by 2 evenly, which means you have an I left over in your answer. So negative 1 to the 9th power is just negative 1, and then we have the I there. So I to the 19th simplifies to negative 1i. Let's say we had a problem that said simplify I to the 44th. So what we're going to do is we're going to take the exponent, 44, we're going to divide it by 2 to see how many I squareds we have. We have 22 I squareds. Since 44 divides by 2 evenly, that means I don't have any i's left over. So I'm just going to say this is negative 1 to the 22nd power, and that equals just 1. So I to the 44th is really just 1. And then one last example like that, I to the 82nd. So I'm going to take 82 and divide it by 2. This time I have 41 sets of I squareds. So I have negative 1 being multiplied by itself 41 times. When I plug that into my calculator, I get negative 1. So, and the reason you might have noticed in the past, there is an I button on your calculator. Your calculator, for some reason, does not handle these well, so it can't do these huge exponents that we're trying to do. So you will actually have to learn how to do these by hand. So pay attention to that when you're looking at it. Okay, next we're going to talk about complex numbers. So the definition of a complex number is they always write them in the form a plus bi. So a complex number has a real piece and an imaginary piece. So this is a real number, and this part over here is an imaginary number. So complex numbers just have a combination of both of those. And you always write the real number first. So the number without the I comes first, then you can write the number with the I. So first it says, we're going to look at an example. This one says 6 plus the square root of negative 16. And they just want you to write it in standard form. And that is the standard form right there, a plus bi. So I'm going to take the 16, I'll make that a positive 16, put an I in the front. So the real part of my complex number is 6. For the imaginary part, I know the square root of 16 is 4, so I'm just going to write 6 plus 4i. Next, we're going to look at an example of adding these. So we have 2 plus I plus 3 plus I. So the first set of parentheses, that's one complex number. The second set of parentheses is the other complex number. A lot of times they'll write them in parentheses just to show that it's like one number. This set is one number, but you don't have to write the parentheses. You could erase it and it would give you the same answer. Like it would do nothing for the problem. So when you look at these, you're basically combining like terms. 2 and 3 makes 5. 1i and 3i makes 4i. Now the nice thing about these is you can actually do all the stuff we're about to do in the video is all easy to do on your calculator. So I went ahead and did the problem. You can see I typed in what I just wrote down on the video, and so 5 plus 4i means I got it right. So when you do this, the little I is right there above the decimal on your calculator, and since it's written above in blue, the way that you get an I on your calculator screen is you hit the second button and then you hit the decimal button right there, and that's what would put an I on the screen. Alright, so next example we're going to look at one that's subtraction, negative 12 plus 10i minus 8 plus 7i. So when you do these, it's just like when we were operating with polynomial functions. You just have to make sure that you distribute that negative. So I've got negative 12 plus 10i, and then I'm subtracting 8 and subtracting 7i. So when I combine like terms, I get negative 20. And then when I do 10i, take away 7i, I get positive 3i. And I'm not going to expect you to do these by hand. You're going to do all these in the calculator. I just want to explain to you how it works so you're not confused as to how your calculator is getting the answer. So there's what that would look like on your calculator screen. All right, next example is 3i times 4 plus 2i. Again, I'm going to show you how to do it by hand so that it's not confusing. So 3i multiplied by 4 is 12i. 3i multiplied by 2i is positive 6i squared. So here when we're doing it by hand, we have to remember that that I squared is actually a negative 1, and 6 times negative 1 is actually negative 6. So right now we have 12i, positive 12i, and negative 6. And this complex number is written backwards. We always have to write the real part first. So this answer is negative 6 plus 12i. All right, and as you can see, when we plug these into the calculator, it looks basically exactly the same as the original problem. All right, so next example, this one is a foiling problem. Negative 5 plus 4i, 1 minus 6i. So I'm showing you these, this first assignment when we're just doing a lot of operations. You can mostly do those on your calculator. There's going to be a point where you're going to have to do some of this stuff by hand, so it's still good to kind of recognize exactly what you're doing. So I'm going to go ahead and FOIL. Negative 5 times 1 is negative 5. Negative 5 times negative 6i is positive 30i. 4i times 1 is positive 4i. 4i times negative 6i is negative 24i squared. And we just have to remember that that I squared again is negative 1. And so negative 24 times negative 1 is positive 24. So that number on the end is positive 24. Now I'll go ahead and combine my like terms. So negative 5 and positive 24 is 19. 30i and 4i is 34i. All right, so there's me plugging it in exactly the way it looks, checking my answer. Now for the last couple problems, they're all division problems. You're not going to have to do these by hand as much, ever, really. So we're going to go ahead and just completely do these on the calculator. 4 divided by 3i, you have to be really careful when you plug this in. Anytime you have multiple things in the numerator or in the denominator, you just have to make sure to put it in parentheses. So on this one, you just have to make sure when you type it to put parentheses around the bottom. So maybe let's write that in our notes. Parentheses around top and bottom if more than, I was going to write that, more than one thing. So the bottom has 3 and I multiplied together, that's why it's like more than one thing. So when I first type it in, 4 divided by 3, that's going to give me a decimal. We don't like decimals, so you're always going to take your answer and turn it into a fraction. And I'm going to show you what my calculator screen looks like. So here you can see what I got first. I put parentheses around the 3i. I got negative 1.33333. And then I turned my answer into a fraction. And so we're just going to write this answer as negative 4/3 I. You can write it with the I next to it. Or you can write negative 4i over 3. And I've seen answers both ways. In this class, we're going to focus more on the answer that looks like that. Okay, and then one last example. We have 5 over 3 plus I, so we want to make sure that that denominator is in parentheses. And then also we're going to get some fraction answers, or decimal answers. We want to turn them into fractions. All right, so here's what I got, my decimals and then my fractions. Now on your paper you can go ahead and write 3 over 2 minus 1 over 2i. Nobody writes the answers like that. They write it as one fraction. So 2 is the denominator for the whole problem. And then the numerator is going to be 3 take away 1i. Or just 3 take away I. So that's how we're going to be writing our answers. That means that when we're doing those division problems, you have to be just a little bit careful because the answer on your calculator screen will need to be adjusted a little bit before you put it on your paper.